later. They asked me also questions. Okay. Okay, you can record it. Okay, let me to start because of my mistake, we are starting late. Okay, I also taught them a few slides. Okay, I will start to synchronization chapter, but from the third chapter, I will just explain round robin algorithm once more in the lecture. I mean, on Thursday, because here it is not easy to draw algorithm, explain. So I prefer to do it in lecture, face to face. So let me to start to lecture. This chapter is related to
So
yes.
So sorry, sir. I want to ask something.
Ask me.
So you're gonna make the assignment quiz about this lesson.
Okay. Look, it will not be like big quizzes. Maybe it will be 2% or something. But yes, from this lecture, I will make a quiz on Thursday. Not to punish you or something like that. I just want from you to listen this lecture and just check what we did. That's why, because generally online lectures is ignored by the students. That's why I'm going to do something like that. Just maybe 10 or 15 minutes of quiz, not a big quiz.
So it's like exercise. So it's not a quiz.
No, it will be quiz. I will just give you some paper. I will write a question related to synchronization chapter, or 2 questions, and you will answer. You will bring me the papers. I will grade them. So it will be a quiz.
So
But
about this lesson, you will write some question about this lesson.
okay, we didn't start yet. Why? Let me to explain the topic.
Yes. I want just to know.
I can give you some questions, but it is not. Look, if you just listen the lecture, just check the slides little bit, it will be no problem in the quiz. It is not like exam. I just want to be sure that these slides are considered by the student. That's
yes. So
Hocam.
my problem is like my question is like I want to know if you have to you can make the question about these lessons. That's what I want to know.
Okay, let me to explain the slides and then we can discuss.
Please continue.
Okay.
Okay. Berkan, sen bir şey söyleyecektin galiba.
Hocam ben söyleyeceğim de acaba şu an quiz, yani bildiğimiz sınav mı yapacağız? Çünkü ben tam takip edemedim WhatsApp'ta.
Ya let me to tell in English. Anlamazsan
Okay.
yaparsın.
Anlarım.
Tamam. Your friend asked me the similar thing. Let me to explain again. It will be just a short quiz. on Thursday related to synchronization chapter. But my aim is to make you to consider these slides, because when you make online lecture, most of the students are not considering, are not interested. They are just opening their computers and they are doing something else. Yani başka bir şey yapar öğrenciler. Çok dikkate almazlar ya. I don't want to repeat this course. I mean, when I stop in some place, I mean, for this slide, I want to continue from that point on Thursday. But I'm 100% sure that if I don't do something like that, no one will consider the slides and I have to start over. Yani en baştan başlamak zorunda kalacağım. Eğer şey yapmazsam ben bilirim yani başıma geleceği. O yüzden I'm going to make 2% or maybe 3% of a small quiz. Okay? So let's make it bonus. So
So it's not about to consider or not, but some people they are not evolving this time.
Let
Maybe
the teacher teach now.
they are
Why
doing
asking?
so
Yeah, let's start our
they
course
cannot be available in this time. So it's not like about to consider or not. So it's not about
Let the
that.
teacher teach now, bro. Why are you talking all these things?
Bro,
People
I'm
have
talking,
to-
bro. I'm talking. I want to tell my what I want to talk. So you cannot say that. Why you want to say that? Why?
But
I want to tell
okay,
what
the
I
teacher said
want
that
to say.
the
So
teacher said that after
keep
they will
calm,
look
bro.
at about
let's
the
talk.
Bro. Keep calm. Okay.
Okay, let your friend to talk. Okay, can you tell me what you are trying to say? Please do not stop him. I don't understand who are talking. Can you tell what you are trying to say? Why now no one is talking?
So please start course, please.
Let's start.
Okay. Let me to start because time is passing.
Let's wait a little bit.
Okay. So okay. Can you mute voice? I'm hearing my own voice. Okay. Synchronization is for more than one process when they are working corporately. We need to synchronize. I mean, order of execution should be preserved. So this is why we are using synchronization. Previously, we only consider, I mean, independent processes, but here we will consider some processes that they are related to each other. So, like when two or more processes are corporates with each other, their order of execution must be preserved. So otherwise, there can be conflicts in their execution and inappropriate outputs can be produced. So what is a cooperative process? Cooperative process is, let's say, one process is producing something. When this process is executed, it is producing some results. And let's say there is another process that it needs that result to continue execution. So these two processes are cooperative processes. Okay. So this kind of processes need to be synchronized to guarantee the order of execution. So here I can explain it better. Let's start from here. Think about that we have a shared memory that there's a file there. And we have two processes. One of them is the task of process 1 is writing, and the task of process 2 is reading, let's say. So if I say what will be the order of execution, you have to say the P1 should be execute first, and then P2 should be execute later. Why? Because P1 should write something to the shared memory, and then P2 can read the writings of P1. Okay, so I can say that P1 is the one who is producing something, and P2 is the one who consuming. Okay, so this kind of processes are cooperative processes. And let's say what will happen if P2 executed first and then P1 executed later. What will happen? P2 will try to read the page which is empty, the file which is empty, because P1 will execute later than P2. Okay, so that's why the order of execution is important in cooperative processes. Okay, and the procedure of preserving the order of execution of cooperative processes is called process synchronization. Okay, so we have a procedure in operating system. It is called process synchronization. Is it clear so far?
No, sir, please. Can you repeat the difference about P1 and P2, please?
Okay. Look, it is already writing there, but let me to just explain again. Look, we have a shared memory here. What is shared memory? Means more than one process can use it. Okay. In shared memories, it can be used sometimes. Several processes can write something inside them there, or sometimes one process can write, one process can read. It is changing according to the need. Here, it is saying that there's a file inside shared memory. P1 task is to write something. Okay, and P2 task is to read something from the file. So let's say in the beginning, this file is empty. Okay, there is nothing inside this file. So if we want to make an order of execution, we have to say P1 should be first, P2 should be second. Why? Because if P1 does not write anything to the file, P2 cannot read it because there will be nothing. Okay, so this is preserving order of execution. This one should be executed first. This one should be executed second. What will happen if I make this one execute first and this one execute second? P2 will be executed first and try to read from the file. But because of no one writes anything here, it will find nothing to read. And let's say second process one will come and write something to it. Okay, it wrote something here, but where is P2 to read it? It already executed. Okay, so these kind of processes, I mean, which the order of execution is important and they are sharing something or they are using each other's products, are called cooperative processes. Okay, and preserving the order of execution, I mean, by using a procedure, is called process synchronization. Is it okay now or not?
It's okay.
Sorry, it's okay. Okay. Okay, it is not something hard to understand. Friends, please, when you attend the lecture, please mute your voice. Sorry, because I'm trying to mute it.
Atom electronic, please. Can you please mute your microphone? Atom, bro, you are disturbing us. Can you please mute your microphone?
So you can close the microphone, everybody microphone there. So you can do that.
Okay, I muted it. Okay,
It's okay now, sir.
yes, I muted. Okay, we have some types of synchronization mechanisms. So in operating system, there are some mechanisms that force the processes to execute in order, in correct order. Okay, so there are mutexes, condition variables, semaphores, upgradable mutexes, file logs, these kind of things. We will see only file logs because the others are actually, if I try to explain these things, maybe I have to give this lecture in third year because you need some, I mean, more programming knowledge. They are a little bit complicated, and that's why I will explain only file logs. Okay. So race condition. Race condition is occurring when two or more threads or processes, you can think, try to read, write, and possibly make the decisions based on the memory that they are accessing concurrently. Okay, so race condition is something like, think about that. Again, we have a shared memory. What is shared memory? Shared memory is a kind of memory that more than one process can have access to use it. Okay, So think about that. We have two processes here. What was process? Programming execution. So we have two codes, two programming lines, and each of them is using the same memory. Okay. So we don't want this one. Race condition is something that operating system doesn't want it. Why? What did I say? The synchronization, the order of execution should be preserved. So there should be a kind of mechanism that avoids at the same time try to write or read to the same memory. Because we can change the results. How? Think about that. This process knows that the count value is 5. Okay? And this one also knows that count value is 5. Process 2. If at the same time two programs can try to have access to this memory, so it will change the result of the program. Okay, so that's why the accessing the same memory at the same time is, how can I say, operating system is developing a kind of mechanism that avoids the access of accessing the shared memory at the same time by more than two processes. Okay, maybe it is not so clear here. Let me just continue in another slide. I may explain it better. Or
Please, can you give just like explication or one is about P1 and P2?
Okay, here actually the image is only explaining the race condition, that if both of them are using it at the same time. What will happen if both P1 and P2 try to use it at the same time? This one will try to increment it. This one will try to decrement it. So according to which one will start first, it will change the results. So here it is not so clear actually what will happen. I will explain to you. Just remember that the definition of race condition, race condition is trying to two or more than two processes, if they try to enter to the shared memory at the same time concurrently, is called race condition. It should be one after the other. It is like using a restroom, toilet. So if we say that toilet is our shared memory, if we make an analogy like that, two people at the same time are not using toilet, yes? I mean, same toilet. So one will use it, then the other one will use it. So, but if it is not happening in real life, but let's say it happens. If two or more people are just enter into the toilet at the same time, this is called race condition. Okay, just know this one, and I will just, there are other slides to explain it better. Okay, so the critical condition. In programs, processes, there are some regions that at that region process will need to have access to the shared memory. Okay, so this is shared memory. This one is shared memory, and this part that need to use the shared memory are critical section. Okay, so this one is shared memory. This one and this one are critical section. Okay, the regions of a program that try to access shared resources and make calls race conditions are called critical section. Okay, so inside the programs, there are some regions that they need to use shared resource, like this one, as I told you. In P1, when it will make count plus plus, it should reach to this shared memory. And here, when it writes count minus minus, it should reach to shared memory. So this count plus plus and count minus minus, these are critical sections. Okay. So critical section, let me to tell you again, are the parts of the program that they need to use the shared memory. Okay. So to avoid race condition among the processes, we need to assure that only one process at a time can execute within the critical section. So what it is saying, we are, I mean, here in this program, to assure that only one process can use the shared memory at a time. I mean, let's say first P1 should use it, then P2 should use it, something like that. So not both of them at the same time. So we have to ensure that only one of them can enter to critical section. So when this one enter critical section, this one will not be allowed to enter critical section, should wait. Because when it is entering critical section, at that place it is using the memory. Okay, till here, is it clear or not?
No.
No. Okay, what is the point that you didn't understand?
Just about critical section.
Okay. Let me to just okay. Okay, critical section are the parts of the program that they are need to use the shared memory. So what is this? Can you tell me? I mean, any of you can tell. This is shared memory.
The set memory.
Yes. Why we are saying shared memory? Because more than one process is trying to reach it. Okay. So when the race condition occurs, if both process 1 and process 2 are trying to have access to the same shared memory, a race condition will occur. So to avoid this, what will happen? We will check the critical sections. Can you tell me where is the critical section in process P1?
Count plus plus.
The count plus plus.
Yes, exactly. This one in P1 and this one in P2. Okay? And think about that if there is any other statement or fragment that it is also using count, that part will be also critical section. But in this part, we only set these two. Okay. So these are critical sections. Let's say critical section of P1 and this one is critical section of P2. Okay, so these parts. So what will happen? Let's say while this process is executing, okay, while this one is executing and it needs, it come to critical section, it is saying that, okay, we have to make sure that P1 will not enter to shared memory. I mean, what does it mean entering to shared memory? If it use critical section, it will use shared memory. So they are just labeling the critical sections of each process. So when one of them is entering to critical section, the system will be warned that this one is entering to critical section, so the others will not enter. Okay, so I hope you understood now. Okay, if it is not so clear, let me to continue. We have another example, so it will be better understood better. Okay. So to avoid race condition among the processes, we need to assure that only one process at a time can execute within the critical section. So I told you that critical section is a part of a program which tries to access shared resources. Okay, like this one. I mean, this part is critical section, this part is critical section. So, and as you see, the non-critical sections is not important because they are not using the shared memory. But when it is trying to enter to critical section, it will be warned. I mean, the other processes, which one is entered first, the others will be warned that the other process is entering to critical section. So shared resource can be a memory location, a data structure, a memory inside the CPU, or any input-output device memory. So any of them, it doesn't matter. I am talking about the shared resource. Just think about it. It is a memory element. So, if we think that the critical section is something like a name that, how can I say, it is like we are going to select a president. So each of us have a potential to be president, but only one person can be president. So not two persons at the same time, something like that. So critical section is something like only one process can enter the critical section. But let me to remind you that critical section is a kind of label. I mean, actually, critical section here is inside process 1, and critical section here is inside process 2. Okay, because it is inside the codes. But here it is trying to explain the meaning of critical section. It is saying that only one process can enter to critical section at the same time. Okay, so if there are 4 processes that using a shared resource, need to use a shared resource, but if one of them is already in critical section,